In this video, I'm going to go over some of the common errors on the week 5 exit ticket. So I'm not going to do the same problems, but I'm expecting you to take a look at this, look at the common errors, and see if you can correct the problems that were on the exit ticket. So you saw that both of the equations had a common factor of x. So they could be rewritten with that x factor pulled out times a quadratic expression like this one. So common error number 1 was forgetting that x equals 0 is a root. So this is always going to be one of the roots. And you want to make sure that's on your graph too, that x equals 0 is a root, so it's going to be an x-intercept. The graph is going to go through the origin. Then we had to use the quadratic formula. So we're going to use the quadratic formula just in the quadratic part of this expression. And we get x equals negative b plus or minus the square root of b squared, that's 2 squared is 4, minus 4ac, so minus 4a times c is negative 4. So minus 4 times negative 4 all over 2 times a is 1, so that's just 2. So we get x equals negative 2 plus or minus the square root of 4 minus negative 16, which is 20 all over 2. The second error was simplifying your radical. So root 20 equals root 5 times root 4, so that's equal to 2 root 5. So we get negative 2 plus or minus 2 root 5 over 2. The third error was simplifying your fraction. And simplifying your fraction, you would get equals negative 2 over 2 plus or minus 2 root 5 over 2, which is equal to negative 1 plus or minus root 5. The fourth error was seeing this and thinking complex. This is not a complex number. This is an irrational number. But an irrational number is real. So this has two real solutions, and that was error number 5. This expression here means we have two solutions, x equals negative 1 plus root 5, and x equals negative 1 minus root 5. So there are two solutions, they're both real, and they are both solutions to this equation. So going back through this kind of problem, first error we saw is remembering that we had a 0 root. The second error that we saw was simplifying the radical, and we want to make sure that we simplify a number here that has a perfect square factor inside of it. The third error was simplifying the fraction. The fourth error was identifying that irrational number as irrational and real, not complex, because it's not negative. And then the fifth error was identifying two unique solutions from the quadratic formula. The second problem on the exit ticket was very similar, but had a negative discriminant. So that one we did get a complex solution for. So for instance, it would look something like this: x squared minus 3x plus 4 equals 0. That one will simplify down to x equals 3 plus or minus the square root of negative 7 all over 2. So we get x equals 3 halves plus I root 7 and 3 halves minus I root 7. We have two solutions here, and these are going to be complex solutions because they have a negative under the radical and an I in the final answer. So these are complex solutions, and there are two of them. And we always see complex solutions, always see complex solutions in pairs. And so these are called complex conjugates And it's the pair of solutions that's a solution to your quadratic equation that are both complex, and they're only different by whether the imaginary part is being added or subtracted to the real part. Please let me know if you have any questions. After seeing this video, you should be able to go back and make corrections to your exit ticket. Thanks.